So today's lesson is going to be on chi-squared independence test. So the symbol for chi-squared is going to be, it's an x with a squared. If you're putting this into an IA or you're writing this down, you don't actually write out chi-squared. You go to insert and symbol or insert equation, and then you can put chi squared, okay? And what this does is you're testing to see if if you have two variables, and if they are independent of each other, which means that one doesn't have an effect on the other. When would you use this? You would use this like in biology to see the efficacy of a drug. Also, you probably have heard in statistics that you say, okay, this is significantly important or significant. There's a significant difference between two variables. That is another way that this test comes about. Um, so we'll do an example in a second. Basically, what you're doing is you're looking to see if there's a significant difference between what is expected versus what is observed. And we're going to go through a couple of definitions before we go ahead and get started on an example, just to make sure that we're good. And again, we talked about chi-squared, which again is you're testing for independence. There's something called a chi-squared goodness of fit test also, which we're going to get to the next lesson. And there is t-tests, which basically compares two means to each other. Okay. All right. So this is an example of how you would use a chi-squared. We'll do the actual math in a bit, but I don't know if you've ever heard that, hey, if you smoke, you are less intelligent, or some people say more intelligent. So you can use chi-squared to see if these two variables, which are intelligence and smoking, if they are independent of each other. Um, that just as an example for something that you need to know for the IB exam, for the paper one and paper two, they won't give you a maximum of, they won't give you more than 4 rows or 4 columns to type in, just because it's annoying to type that in. And if we look at this example right here, again, we're going to be able to test to see if we took the data on people's intelligence, like from an IQ test, we can see if that has an impact on whether they smoke or not. All right, if these two are correlated. So this here is the formula. You do not need to know it or memorize it for your exam. It is not needed. However, if you are doing this for your IA, this is good to go ahead and do a quick video or look at the textbook about how to use that. Um, there's what you're doing is you're using the chi-squared statistic, and that is a number that you can use to make a decision about the data. Null hypothesis, the symbol for that is H with a subscript of 0, so HO. And that basically is saying that the two variables, in this case, this example that I'm giving you, that intelligence and smoking, are independent of each other. That is the null hypothesis, independent of each other. Okay. The alternative hypothesis, or the alternate hypothesis, is that the two variables, that's H1, that the two variables are not independent, that actually they do affect each other. Okay. So some more definitions. This is called hypothesis testing. It's the branch of statistics that is called hypothesis testing. There is something called a critical value, which tells you, this comes from the table, and you will be given the critical value. There's also something called a significance level, and that basically is telling you like how confident you are to see if the two variables are independent or not. So 10%, you are 10% confident that this is what you're saying is correct. 5%, 1%. 1% obviously is the most statistically solid decision, right? And so the percentages just over here real quick. If you are 10% confident that your data is correct, or if the variables are independent of each other, how you put that into the calculator is 0.1, right? Because you have to move the decimal over 2 places to the left. 5% is 0.05 and 1% is 0.01. Okay. Degrees of freedom. The way that you get that is degrees of freedom is a symbol, and how you get that is you do the rows minus 1 times the columns minus 1, and this is a fixed number based off of your table. That is not really going to vary. On the exams for your IB, the degrees of freedom are always going to be more than 1, okay? Whereas in real life, they might not be. This is just like a little meme, the value of P. Okay, so P, what that is the probability of getting that answer or that result based off of chance. And the calculator will give you the P value, the degrees of freedom, and the chi-squared. So how do you do this, right? How do you actually do this? So the first thing you want to do is you want to write out the null hypothesis, which is that, again, that the two variables are independent of each other. You want to put it into your calculator on the TI-84, which is the one that we have in school. You go into matrix, which we'll do in a bit. And then you're going to do the chi-squared test, which is stat test chi-squared. You don't say x-squared. And then this is very, very, very important. You do need to memorize this right here. So let me just move this up. So if the p-value, which the calculator is going to give you, is less than the significance level, which again, this is typically given on the exam, then you are going to reject the null hypothesis. Okay. So one more time, if the p-value is less than the significance value, you're going to reject the null. Also, if the chi-squared is greater than the critical value, you are also going to reject the null. So there are two cases. Okay, if chi-squared is greater than the critical value, you're going to also reject the null. Okay, so how do we actually do this on the calculator? So first thing we want to do is you want to look at what the significance level is. So 5%. So again, that's 0.05 because we're moving that decimal 2 places to the left. And we want to see if the two factors are independent or not. So how do we do this? So we take our calculator. We go ahead and turn this on. Okay. Please do this with me. Don't just watch me do this. So you see above, there's a second button of alpha, math, and a x to the -1. But above that, it says matrix. You're going to hit second and x to the -1 power. Okay. The next thing you're going to do is you're going to go over to edit. So go to edit, and you're going to hit enter right here. And you're going to tell the calculator, right? So we're putting this into matrix A. You're telling the calculator how many rows you have. So there are, the rows that we have are 1, 2, 3. So there are 3 rows, and the number of columns are 1, 2, 3, 4. So there are 4 columns. So all I did in my calculator, I went ahead and did this just so I don't have to sit here and pause the video or make the video longer, is a 3 by 4, right? Rows by the columns. And then you put the numbers in, 279, 386, so on and so forth. Okay. After you do this, the next thing we want to do is we want to go to the stat menu. So let me just quit out of here. So we're going to go, let me clear that. You want to hit stat, and you want to go over to test because we are doing a test. Okay. And you want to go to the one that says chi-squared, which is option C on this calculator. So you're going to hit option C. You're going to leave all of this the same, right? So this is our observed, which is what we just found out. What we typed in is under A. Your B, you can leave it as expected, and then you're going to hit calculate. And it's going to give you the 3 values. So it's telling us that chi-squared is 16.917, the p-value, and it gives you the degrees of freedom. Okay, awesome. So now let's go back to answering our questions right here. So what is the null hypothesis? So the null hypothesis is that intelligence and smoking are independent of each other, so that the two variables are independent. What is the chi-squared statistic, right? So the calculator just gave us that. So that's 16.917. So we could go ahead and write that down. So 16.917 kind of keeps going. 3 significant figures is going to be 16.9. All right. What is the value for the degrees of freedom? So the calculator gave us that the degrees of freedom is equal to 6. And again, we got that by row -1 times column -1. But the calculator is nice enough to do that for us. So the degrees of freedom is equal to 6. And what conclusion can we make based off of this? Okay, so to do that, okay, so what we can state from this, so what conclusions can you make? Before we can do that, let's go ahead and write this down. So our p-value, which is the one that we missed, is 0.00959. So p-value is equal to 0.00959. Why did my calculator go off? On. Okay. 0.00959. Let's see if I can just go ahead and put this here. Yep, perfect. 0.00959. So 3 significant figures. We're good with that. So remember what we can conclude now, right? So our conclusion is if the P is less than the significance value, right? Significance level or significance value. So our P right now is 0.00959. So we need to ask ourselves, is this less than our significance value? So going back up here, our significance value was 0.05. So we can put 0.05 and the answer is yes, right? So we are rejecting the null, because our p-value is less than our significance level. Okay, so what conclusions can we make right now? So what we just did, since we are rejecting the null, what we can say is we can say that smoking, let me see if I can just go ahead and write this down. So smoking and intelligence are not independent of each other, which means that somehow they are related to each other, right? If they're not independent, that means that they are somehow related to each other. So that is the only thing that we can conclude. This is actually very powerful, right? So now we know that they are somehow related. So you can do some other tests to see how they're related. But we do know that at this point that they are related. So to figure out like further, you could see if they are monotonic, like if one increases with the other, and maybe do another test that way. So I know some of your IAs actually go into this a little bit, but this is just how it's going to be used and how it's powerful. Okay. So what I'd like you to do is to pause the video right now and go ahead and do these questions and come back to the video so we can go over it together about how to do question numbers 1, 2, and 3. Okay. All right, so hopefully you went ahead and plugged this into the calculator. So for this first question right here, let's go ahead and look at this. So it says for part A, write down the total number of computer users surveyed. So you're going to go ahead and just, you can extend these lines right here. And we're going to total everything, right? So 20 plus 18, that gives us 38. This is 38. This is 73. This is 59, right? So we're adding these right here. And then for across, you're going to add 20 plus 25 plus 22, which gives us 67. If we go ahead and add 18, 48, 37, that gives us 103. And then the total number is 170. So write down the total number. So n is equal to 170. There are 170 users altogether. So part A is good. Part B. So write down the null hypothesis for this test. So what are we talking about? Our two variables are going to be preference of either Mac or computer. So preference of computer type, right? So that's one variable. So our H0 is that preference of computer type. Preference, okay, of computer type is independent of, and what are we looking at? Ages, right? Of age range, let's say. Okay, so that's going to be our null hypothesis. So now we're looking for the chi-squared statistic. So we go, remember, just taught this, is after you put the numbers into the matrix, so second matrix, and we put it under, so number of rows 2 by 3. The next thing you're going to do is you're going to hit stat. You're going to go over to tests and go to a chi-squared test, which is right here. And then you just keep hitting enter, 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 and it gives us our variables, right? It gives us chi-squared is 3.71. You can round that. So chi-squared is 3.71. Well, we could use the about symbol. Okay. The critical, they're telling us that the critical value is 5.99. So now we can see that the chi-squared which is 3.71, compared to the 5.99 is less, so less than 5.99. So we have to remember what it is that we did back here. So if the chi-squared is greater than the critical value, we reject the null hypothesis. So since the chi-squared value is less than our critical value, we're going to accept the null hypothesis. Sorry. All right. So we say we do not reject the null hypothesis. Okay, we're going to accept the null. Good, we've done part D. Okay, so now I'm going to give you some time to go ahead and do the next question. All right, so for our next question right here, we have, all I did is, since I was given the totals here, I went ahead and did, or found the totals here. Just go totals. All right, so 92, 82, 174. So the total number of all the families who own cats and broken down is 174. So it says write down the expected number of female Persian cats. So females, and there are 82 females altogether. And Persian cats is 31. So we're taking this and we are multiplying 31 times 82. And we are taking that number and dividing it by the total number, which is 174. So this kind of goes back to expected number. So 31 times 82 divided by 174 is going to equal about, this is about 14.6. So 14.6 is our expected number. Okay. So chi-squared was performed at the 5% significance level, so that's 0.05. And it is used to determine whether breed preference is independent of cat gender. So I went ahead, I took my matrix. So let me just show you what I plugged in. You're not plugging in the totals, okay? Don't plug in the totals. So it's going to be a 2 by 4 because there's males, females by 4, British, Persian, Siamese, Scottish, and that's what you put in. So again, like I said, do this. Don't just take my word for it. Actually plug this in yourself. And then you're going to go ahead to get to the chi-squared. We're going to go to stat tests. Oh, that is not the test I want. So stat tests. And we're going to go down to letter C, which is chi-squared test. And you're going to hit enter, enter, enter a bunch of times till it gives you the actual values. Okay. So our p-value is important, so that's about 0.346. So our p is about 0.346. 3.346. Okay. So we used our graphic calculator to go ahead and figure that out. So that is the p-value. And now we're going to state whether it's independent or dependent, right? So our p value, which is 0.346, is less than, is it less than 0.05? No, it's not. It's greater than. So this is greater than our level of significance, which is 0.05. And boom. Okay, so now this is a different case, right? So state whether they are independent. So since the p-value is greater than our significance value, we do not reject. So we do not reject the null, right? So H, I'm just going to put a little O here, right? So we do not reject the null hypothesis. So therefore, breed preference is independent of the gender. So let's just go ahead and write that. So breed preference is independent of gender. Okay. All right, good. So that is our second question. All right. So for our last question, awesome. Question number 3. First thing we're asked to do is we're asked to find the value of k, right? So that's actually pretty easy because the total is equal to 45. So you do 45 minus 16. minus 15 minus 8, and you'll get that the value of k is equal to 6. The degrees of freedom, you can let the calculator do this for you by plugging in this matrix right here. Or you can remember that row minus 1 times columns minus 1 is equal to the degrees of freedom. So if we look over here, we have, there are 4 rows. So we could do 4 minus 1 times the number of columns is 3. So 3 minus 1, and that gives us 6. So our degrees of freedom is equal to 6. Okay. For the next one, for letter C, use a graphing calculator to find the chi-squared statistic. I think we've done this enough that you can plug this in yourself. So you will get that the chi-squared statistic value is equal to 18.1 when I did it. That's what I got. And state the conclusion for this test, right? So we do know that the critical value is 12.6. So since our chi-squared, which is 18.5, so since our chi-squared, which is 18.1, my bad. Since our chi-squared, which is 18.1, is greater than the critical value, which is 12.6, what we can do is we can reject our null hypothesis. So we reject our null hypothesis, and they gave us what the null hypothesis is. So the preferred toy is independent of the age. We're going to reject that, and therefore that's enough to conclude that the preferred toy is not independent, right? So we're going to accept the alternate hypothesis. So we say the preferred toy is not independent of age. So let's go ahead and write that. The preferred, and we're going to use their words, right, is not independent of the age, right? We're just taking their alternate and we're accepting the alternate because we're rejecting the null. All right, great job.